Ladies and gentlemen, good day to you. My name is Michael Lloyd, and together with Allan, we're going to be giving the first part of this talk to you about enclosed spaces and the problems that we've encountered. Then we're going to be followed by Drew Korek, who is going to be talking to you again about something very new, which is enclosed spaces in the diving fraternity. So first of all, we'll get going as to why we're going to be talking about it to you. About 10 years ago, it suddenly became fairly apparent in the marine industry that we had a problem. And this was the accidents and deaths occurring in enclosed spaces on ships. Now, at the time, nobody seemed to be doing a lot about it except talking. I suppose really because nobody knew very much about it. I decided that we should have a paper to start this off and give us an idea of where to go. And so I started to write it, and then I realized that I didn't know a lot about it either. So I asked around for someone or somewhere where there was enclosed space expertise that we could use. And the natural people seemed to be the mining side of things. Now, why was that? Well, if you go down a double bottom on a ship, it's very similar to a mine. And that was my thinking when I approached the Mines Rescue Service. And these are the chaps that stood by 24/7 to rescue people from all the different mines that we had in the UK. And they'd been doing it for 100 years, so if they didn't know, then there was going to be nobody else in probably the world that knew what to do. So I contacted them, and very luckily came across Allan, who was quite an expert, and together we formulated a paper. And that was the start of this kind of journey that we embarked on that became Mines Rescue Marine. From our experiences together, you're going to see a little bit of what we found out and what we tried to do about it, and what knowledge we tried to pass on to those at sea and indeed those ashore who were going onto the ships and also dying in enclosed spaces. So without any more time wasting talking to you about why, I'll pass you on to Adam, who will now deal with what the concept was.
Hi there, my name's Adam. Originally when Michael approached us, it was approximately 7 years ago, there was a great deal of intrepidation about this. We couldn't understand that there was any synergy, or if there was any synergy between the marine industry and the mining industry. So realistically, before I consented to go and help out, we needed to really find out, what we're up against, because I didn't know your industry at all. So to get a handle on where we were with this, we arranged to get on board some ships. Now, you'll be familiar with these ships, or these types of ships, but the first ship that went on board was the Ro-Ro ferry, the one in the top left. Went into the double bottom there, and I'd never seen anything like this before. But we had to get into this, the exercise in it with our people, just to make sure that we could do what we think we can do in your environment. So we did, and we succeeded. And from that, we went on and had a look on an RFA ship, we had a look on a North Sea supply ship, a cable layer was made available to us, as was a tanker. And each of these vessels we exercised, each in different circumstances, just to prove to ourselves that we can do what we said we could do. So we didn't stop at that. We said, okay, the oil and gas industry is akin to the marine surface ship industry. So we had made arrangements through friends of ours in the oil and gas industry to go on board various different installations, such as FPSOs, FPUs and FSUs, and we've been on board all three there. So that was going to give us the insight that we needed, really, to have a look-see and concede the fact that, yes, we can offer some help here in this enclosed space situation. So once we'd been on board these different vessels and installations, and we'd agreed that between ourselves, I hasten to add, that yes, we could offer help here, and we had some skill set that we can offer into the marine industry, we decided to outline a direction that we're going to go in. So Michael Lloyd and myself got together. We decided, or Michael did, because he knew it's your industry, his industry. He knew where he wanted to take us. And we then set the focus. And from that, the Mines Rescue Service, which set up a division called Mines Rescue Marine, and it's now MRS. The focus now is on the marine sector. So that's the reason we got to where we are today.
Right. Now, in looking at it, we realized that we had 4 main problems to try to tackle. Equipment, training, design, and culture. Now, I'll say this. Now, I quickly realized, and I think that Adam and the boys did, who we sent on board the ships, because they were the ones crawling through these spaces, that design was the one that seemed to be forcing the other 3. I mean, if you had a nice room and you could walk into, and it had good ventilation and lighting and everything like that, you wouldn't need the rest. But as you know, on a ship, well, the whole ship is a massive enclosed spaces, but the average enclosed spaces that we're talking about are not like that. And one of the worst things we found, of course, was getting into these spaces and even working in them. It was as if the naval architects or whoever was designing these ships just didn't think that people had to get in and people had to work there. Anyway, from this, of course, the other 3 came: equipment, training, and the culture. And here's the thing, which we found out. Again, one of those things that you think just couldn't exist, and that is that, you know, the manholes that we're all crawling through, they're a standard size in the marine industry. That size was used 100 years ago. And we're still using the same size for manholes today. And when you go and you ask the architects and the builders, and the designers, why, they can't really give an answer, except that no one's asked them to change it. Now, it sounds weird, but that is the answer that we receive, is that yes, they could make them bigger, but no one's asked them to. Adam, all yours. Quickly here. This is the box I was telling you about, okay? And we designed this because we looked at the fire triangle, which you all know. You've got, you know, the fire triangle. Well, this is the enclosed space box. And this is pretty well gone around the world now, and people are actually using it as a standard to show the problem. And we'll now have a look at each of these problems. Adam.
Now, as Michael stated, you know, we come up with the 4-sided enclosed space box because we identified that each of those 4 elements impacted directly onto operations within enclosed spaces. And when we did some research, what we found that all the regulations in relation to tank design and apertures for going into tanks related back to bulk carriers and tankers. And it stated that the minimum size requirements for the apertures or lightning holes was in the region of 800 by 800 for vertical and 800 by 600 mil for horizontal entries. Now, this did lead indeed to strange design features, and perhaps I can show you a few of these as we move this forward. So going into these spaces, as I stated earlier, on both ships and installations, things were becoming apparent to us that perhaps you guys couldn't see, simply because you're involved with it. You don't see the trees because you're already in the forest. But it was apparent to us that there was a design problem here. And perhaps we can share a few of these with you. Now this shot, for example, is one of my people is in the bilge. And what he's doing here is, you know the space, we never knew it, we just got shown to it. So we've got to formulate ways of getting people out, rescuing people from these very, very tight spots. You know, what you can see here is this guy is something like 6'3" in height. It's about 16 stone in weight. And what we decided is we were going to put a harness on him. Now, this is a thing that you guys don't normally do. And we'll discuss equipment in a bit. But we've put him in a harness. If you look at the bottom middle of the picture, you can see a sort of D-link there. That's attached to a winch. And we can do a harness rescue. And that's the type of rescue that we adopted for this chap, getting him out of this bilge compartment. But both his shoulders are on either side of the lightning hole. So what's become a standard size that I subsequently found out is 600 millimetres in height by 450 millimetres across, an oval shape. And that's now accepted as a standard size. This is the thing that we couldn't come to terms with. The second shot I've put there is just to give you an indication, and you've seen them. You've seen them. This is a deck entry into a main tank, into a ballast tank. Again, you've got the oval shape, which is the standard lightning hole size, which is 600 by 450 millimetres. But just to get some perspective on it, the guy that's the winch man, he had to put his boot, you know, into the space to give him some purchase to operate the winch. Now, he has a size 11 boot, and as you can see from that, he's almost midway across the lightning hole entry point. But to prove that we could do it to ourselves, and thereby show other people that it can be done, the injured party, or pretended injured party, is a life casualty. It's one of my people. We put him onto a stretcher in the tank. It's a Paragard military stretcher, and you can see him being hoisted vertically out of the space. The third shot came as a bit of a surprise to me. We had actually gone to a ship. It was a cable layer, the one I showed earlier, to overview an emergency drill. It was an enclosed space drill we were going to hold on the day. And as we arrived, the senior management staff on the ship decided, no, we'll cancel the drill for that day. So I says, that's fine. Fine, but it was a Saturday morning and we'd given up our time to go along and assist on this. But the captain quite rightly came off and invited us on board and invited us to go around the ship with him and have a look at the areas that he felt might be problematic to him. And one of the areas he showed me was this. And when I saw the entry point, I couldn't believe what I was looking at. It's difficult enough getting into a 600 by 450, I'm sure you'll agree. But when you put a cableway across the front of it, it becomes almost impossible. Now, the shot on the right-hand side shows the inside of that tank. And that's our people in there. We've actually put the casualty onto a stretcher and we're ready to extricate him out through that manhole. And when I said to the captain, how, under normal circumstances, well, abnormal circumstances, how would you get the chap out? He says, well, I would cut the girder work with a burning torch that's up to the right-hand side of the entry point. I says, I think we can maybe get away with doing something a bit better than that. So we brought the chap out, and we actually managed to get him out over the top of the cable run. Between the top of the manhole and the top of the cable run, we had an angle to get him out. So we successfully extricated the person over the cable run and out of the space. Now, the fourth design shot that you can see here was, I mean, this was the worst I'd seen. It blew me when I went into it. What you can see here is it's a four-peak. It's on the RFA ship in actual fact. And the entry point is the one that's in the foreground that you can see. We're looking down into the hole. It's a standard 600 by 450 entry. But the subsequent entry into the lower part of the compartment, going down, as you can see the guy coming up through it. The ladder is now through the manhole, and it makes it even tougher for getting in and out of the space. Now, what is a standard 600 by 450 is now foreshortened by the width of the ladder, and as you can see the shot, the base of his helmet is actually touching the edge of the hole, and the peak of his helmet is touching the ladder. With this, for someone to go in and out of there, that would be difficult in its own right. To rescue someone from there would be very, very difficult. And that's the sort of things that we'll be coming across when we're looking at design. So I've no doubt that you guys have seen that on a daily basis, but that come, you know, as a shot in the arm as far as we were concerned. We didn't realise that this existed. And that's one of the reasons that we have made design one of the main features of the problems associated with enclosed spaces in the marine industry.
Yeah. Well, if you think about that last shot you saw, where that ladder is going down through a manhole. Now, just think of the number of people that saw that when that ship was being built. I mean, you've got class there, surveyor, watching things. You've got the owners, you've got superintendents, you've got the captain of the ship, you've got all kinds of people. And it just went ahead. Nobody actually said, just a minute, how are we ever going to get somebody out if something goes wrong? That's one of the problems, isn't it? Well, now we're going to move to equipment. And here we go. A simple fact. Entry into and rescue from ship's tanks requires specialist training and equipment, and the majority of ships don't have it. Recently, we had a case of the British ship. Well, she wasn't a British ship, but we flagged don't have many of those left. But she was a ship belonging to a major British company. In fact, the largest British company. I think it was 2 guys or 3 guys. I think it was 2 guys died in an enclosed space off the West African coast. And the only equipment that that ship had to get them out was a length of rope. Now, just think, this is 2017 what we're looking at. And the length of rope is being used to get people out of space. And the most incredible thing, of course, is that we have the IMO, and there's still no legislation required for any specialist enclosed space equipment. In fact, there's no legislation for training either. They say there is for drill. A drill isn't training, but we'll get onto that. So we've got no legislation for equipment. Now, luckily, there are those companies out there, unfortunately a few, but those few do provide equipment and do provide training for their people. And they do it for a reason. They did it for a good reason, and that is, one, hopefully it's going to save lives on their ships, and secondly, it ensures that they're not going to end up in court because of people dying in these spaces. So that is the thing of equipment. Now, will any equipment do? Right, well, there it is. There's the recent accident and the length of rope. Now you can see that that is obviously not right for a ship. There's 2 types really of equipment you've got to look at. One is the equipment that you're going to wear to go into a space, just to work. And the other equipment is if something goes wrong, then guys are going to have to go into a space to rescue, get people out. And these are 2 very different types of equipment that you're going to have to look at.
So it's back to me again, guys. We're going to look at equipment. Now, being the second part of the enclosed space box, this is another very important issue as we saw it. We do a lot of rescue work and we do a lot of work on shore. And to go into an enclosed space, we deem as best practice that you should actually carry equipment with you. And the equipment that we suggest that you take in is an oxygen meter as a minimum. A multi-gas detector would be more beneficial. The multi-gas detector being 4 gases, for example, oxygen being one of them. We also suggest you take in mobile lighting, as you do, and we have seen the hand torches that you use, and I'm going to show you a comparator just in a minute. You should also take communications equipment in with you, just in case anything goes wrong, so you can communicate with outside the space. We recommend that you should wear a rescue harness, and a lot of people will just sit back in their seats when they see this. But the reasons for that is, it's not the awkwardness on you getting in, It's in case something goes wrong, the people that's got to come and get you, it helps them get you out. And of course, dependent on risk assessment, you should always be taking in an EEBD, emergency escape set, which is giving you 10 minutes of air should the situation deteriorate rapidly whilst you're in the space. So as best practice, we recommend that you should be taking these pieces of equipment as a minimum and with you to protect your own lives. Now, just to show you a comparator here, normally when we do this talk, we do it from a platform, and I can take a couple of my people along with me. And when they're there, it becomes stark. Trying to do it in two photographs is a bit different. But the photograph on the left is a guy taking in with him standard equipment. You can see looking at him, the big thing that's hanging around his neck, the orange plaque, is an escape set. In his right hand, he's holding a torch here. In his left hand, he's holding his comms equipment. And round his neck, dangling round his neck, you can see a gas detector. Now from that, and I've no doubt you do a lot better than this, and I've no doubt that you have your own ways of doing this, but that's what I've seen when I've gone, and that's if they take an escape set in with them. But what I've seen is they're going down ladders, trying to juggle all these different pieces of kit, trying to hold onto the ladder at the same time as they're going down. And that's not acceptable. Your safety has got to come first. You should always have 3 points of contact with a ladder as you're going down in any case. So, to enable to overcome that, the picture on the right-hand side gives you an indication of how we see a guy going into a space. On his helmet, you can see his torch. That lights the way. On his lapel, you can see his gas detector, and it's deliberately located there because it's up near his face, and it's detecting any gas that's in the vicinity of his face. His comms equipment is a headpiece and a mic in front of his mouth, so he doesn't have to juggle that. He's wearing his harness underneath. You can see the straps. And around about him is his escape set. It's a jacket type. It's one that we've seen on the market. It is available, and it makes it a lot easier than having to take one of these things round, and it's rolling around your neck. So that's how we see the future. That's how we see it as is at the moment. Michael.
Yeah, the problem with equipment on the ship is because enclosed spaces have never been treated with the seriousness of fire, we've ended up with legislation requiring fire equipment. And that equipment has become the be-all equipment for the ship. Now, really, think of it this way. Fire equipment is for fighting fires. You know that when you put those BA sets on that are provided for fighting fires, you try and get down one of those manholes with that on to rescue someone, you're not going to do it. You're not going to do it. And indeed, that was proved on a ship that had an accident up in the North Sea. And they tried to go down with that on, and they couldn't get through the space to save the guys. Simple as that. So fire equipment for fire, enclosed space equipment is for enclosed spaces. And if we could actually get that across, then I'm certain that, again, we're looking at saving lives. Now, why is the confusion existing between drills and training? Well, the confusion is caused by the IMO, because the IMO are the ones who persist in using this word drill. Let's get it right. A drill is purely done to show that the training that the men have had is suitable for that situation at that time in that place. That's what a drill is. And notice the word training. You cannot have a drill without people being trained for the job in the first place. And somehow, hopefully, this might filter through to the IMO that there is a distinctive difference between these two things. And what we're after is training. You've got to have training in the use of equipment. You've got to have some training as to how to prepare yourself for going into a space, what to look for before you go in, what the officer in charge has to do to watch while people are in. All of this is there to stop people dying. Now, very few ships carry out enclosed space entry and rescue training. Very, very few. The problem is that, look, almost everybody now knows all about enclosed spaces. Everybody knows that there's training available. And yet, so the question has to be, why are shipping companies not having their people trained? Well, I'll tell you why. Because there's no legislation. We've got a mantra in our industry that says, if there's legislation, we do it. If there's not, we don't. And this is not very helpful when it comes to safety. Because, unfortunately, the structure of the IMO, it takes about 15 years to organize a cup of tea almost. So if it's going to take that long, you can imagine that, you know, the IMO is way behind modern thinking. So if you're going to wait for legislation, deaths are going to carry on. And what we're trying to say is, look, training is available. For God's sake, get some people trained. If you don't train everybody, at least get your senior officers into a situation where they understand what it's all about. And you stop this macho idea that when I was a cadet, you know, I went in without a problem, so I can go in now and the men can go in because I went in when I was a kid. I used to say that too. And I look back and think how stupid it was. If they understand what's going on at sea today, and don't forget now we've got more bigger ships, more enclosed spaces, less crew to get people out, less crew to have on standby. It has to be planned. In other words, you've got to manage your spaces. And that is another new concept that we've got to throw at the ships. Adam, all yours.
Thank you, Michael. Well, Michael has touched on training very, very briefly and did the comparator with drills. And it's stark. You know, to do a drill, you must be trained to do a drill. So I'm going to take that a wee stage further, and we're going to have a wee bit look at training. Now, I know you're sitting there looking at this online or wherever you are, drinking your cup of tea, and you've dropped the tea off the edge of the bench, and you're wondering, why is he showing us this picture?
I love it, this picture.
Now, if you care to look at the bottom line first, this picture was taken in 1917. And what you're looking at here is a fully trained and equipped mines rescue team that the coal mining industry put in place in the event of a disaster occurring in a coal mine. Each of the people that are sat down are wearing a long duration breathing apparatus, and it's filled by an oxygen cylinder. So you're getting 2 hours use out of the breathing apparatus. On the floor in front of them is a couple of canaries. And I know you're just choking on your tea now again, but that was a means of detecting gas. The marine industry only introduced oxygen gas detectors as mandatory in 2016, nearly 100 years later. The 2 pieces of kit on either side on the floor are what's known as oxygen reviving equipment. Now, this was in case you come across someone who was unconscious or partly conscious, and in an atmosphere that wouldn't sustain life, you were able to fit the oxygen reviver and help the chap get out of the space. Now, these pieces of kit and these people you're looking at is 100 years ago. And that's really what the point I'm trying to draw out of this. Now, when we look at training, we must look at, obviously, at effective rescue training as well. And the points that we need to look at when we start talking about effective rescue training is who's going to do it to begin with. So we need to look at the people that we select to do it. Now, in the various installations that I've been on, and I've asked the questions because I've been asked to do audits on these installations whilst I've been there. When I asked the question about the fire team, because they're the team that's expected to go into the enclosed space, by the way, and bring people out, how do you select them? And I was told that the fire team leader was normally the deck superintendent. I says, yeah, well, fine. And what qualifications has he got for to go in and do rescue? And has he been trained to do it? And training courses has he been on? No, he's the deck superintendent, so he's the fire team leader. And that was the explanation I got. Now, this is quite a specific task that you're asking someone to do. You need to make sure that they're prepared, not just physically, but mentally, to go into this space and have the skill set to do it. So you really need to be selecting these people. You don't just want to be shoving them in, hoping for the best. You need to be looking at specific rescue equipment, some of which I might show you in a bit. We would recommend this. You need to look at competence training. You need to put them through courses so that you're giving them the confidence to go in and do what you expect them to do. At the end of the day, there could be someone at the other end of this in the space, and you need to get them out. And if the people going in doesn't have the skill set to get them out, we need to give them that skill set. So you probably need to train these people correctly. And one thing that we do, and I'm not advocating that you do this, but we familiarise the people with the spaces and environments that they're going to be operating in. We take them there, we put them into it, and we carry out rescues from it. So our recommendation is that you should select your personnel, you should select the equipment specifically for the job in hand, you should train them so that they're competent to do it, and you should make them familiar with environments in which they're going to perhaps have to rescue people from. Now, with regard to rescue equipment, this is a selection of equipment that we actually take on work with us. As I say, we're not just talking about this as a theoretical piece. We do this for a living. And the type of equipment that we take with us when we're on a rescue cover job, or when we're providing rescue cover to whoever may require it, the first thing you need is some means of getting somebody out should they be incapacitated. And we would suggest a stretcher. Now, the stretcher we use is the Paraguard. I've seen them on ships, but when asked, the people don't know how to use them because they've not been made familiar with them. They also have other types of stretchers, which I feel they're all good stretchers, but we feel that this is the best and available, so that's the one that we use. The Deco 2000 is a man-riding winch. It will lift up to 150 kilos. It can be operated by one man, but it needs an anchorage point. The anchorage point that we select is probably a tripod. It doesn't have to be. You could rig slings and you could put carabiners up, or you could use any other anchorage point you've got available above the entry point, and you can hook on the man-riding winch and you can extricate the person doing that. We also take along with us the defibrillators in case someone has had a heart attack or their heart has stopped. Obviously, first aid equipment, because our people are first aid trained. Oxygen reviver, that's imperative. That's to give the person who's in the space, incapacitated, the ability to breathe whilst in an atmosphere that may not sustain his life. Analgesia, and obviously to protect the entrance, to protect the rescuers, OCBA. This type of OCBA is a jacket type. It's a slimline cylinder. It makes the trunk much thinner for getting through the 600 by 450 lightning holes, and that suits a lot better than what is the standard cylinder size that you use on your breathing apparatus at the moment. And that's our recommendation. That's what we see as best practice. We cannot make people do it, but we're giving you a view of what could be used.
Yeah, what could be used.
Now, just to show you the facts that we have undertaken rescue on ships, this is my people extricating a person out of what is a fourth peak. You can see in the right-hand picture is on the stretcher, there's an oxygen reviver fitted to him on his face, and he's actually coming up through the lightning holes within the fourth peak. The second one is on a Royal Navy ship, I hasten to add this one had gone into for refurb, but it was going to be made into a cadet ship, cadet training ship. But nonetheless, they asked us if we could, if we asked if we could exercise, they gave us this area to exercise in. And you can see from the pictures, you know, it's a very, very tight environment to try and rescue someone from. We used a different paper stretcher on this occasion. It's called a sked. It's the one in the right-hand picture. It's made predominantly out of plastic. It's really meant for rescuing people off mountains. It's more a
slide
type stretcher, yeah. This was a very difficult rescue for us. It's in a pump room. You'll be familiar with the pump rooms. What we decided, instead of trying to lift the guy straight up from the bottom deck, straight onto the main deck, we decided to bring him up from deck to deck, up the inherent stairwells, which are narrow and only have passageways, as you can see where our people are, that are quite narrow, and made the extrication very arduous, but nonetheless accomplished by 2 people. And we had to do this to prove to ourselves that it can be done. But we found that really tough, that one. And this I've no doubt you're familiar with. You'll see it regularly. It's a DD. That's the double bottom in the Ro-Ro that we exercised in first. And I must admit, when I saw that and saw the environment you guys were working in, it took me aback. I says, can we do this? So we had to go in there, we had to look at the situation, we had to set up a mock rescue, and then we did it. So that's the guy coming out, life casualty, on the paragraph stretcher, coming out through the DB to show ourselves, first of all, that we can rescue the person. Michael.
Right. Now we head on to responsibilities. Now this is an interesting one, because you'd think that by now, I don't know, how long have we had ships around? I think the Romans had them, the Greeks had them, and Noah had one. And still, a lot of people are confused about these responsibilities. In other words, who is responsible on a ship for what happens and what goes on? Right. This is by Hopkins. I don't know, I mean, you guys, many of you guys, master mariners and stuff like that, you know Hopkins backwards. But this is what he says, and nothing's been better said. It lays it out that the master is responsible, not only through marine regulations on the ship, but common law, certainly in the UK and in all the Commonwealth. That's the common law. And I suggest to you it's the same in many other countries. The captain is there and he takes responsibility. Right, let's have a look. What about that? Now that's in dry dock. And I don't think there's any surveyors standing there. But who's responsible for these guys? You have a look at that. Is it the foreman? How about the company that employs them? How about the dockyard? Maybe they're responsible. Or possibly the safety officer who's sitting up there ready to fall down and demonstrate how to recover from a fall into a hold. Right, let's have a look. That's the dry dock. Horrible places, but again, as surveyors, you know those. That dry dock believes, in many cases, that it can assume responsibility. They come on board with a bit of paper and they get the captain to sign it. And it says that we'll take responsibility for all safety of the dock workers on board the ship. Well, that's absolute rubbish. That's a document that has no legality, and you might as well take it into the lavatory because it has as much use. The master is responsible. As long as that ship has got its ensign flying and that master is signed on that ship, he cannot avoid it. And even if he tried, you've got a guy called the safety officer on board. So the master signs that bit of paper. Well, what about the safety officer? Has he signed it? Has the DPO in the company office signed it? No, they haven't signed it. So let's stop this nonsense about the docks being responsible. It's not that, it's the master responsible, and that's where it ends. Now, that means that he is responsible for your safety on board. As surveyors, going on board a ship. And honestly, I've seen you guys take some appalling risks on a ship, assuming that the ship's done it all. Now that is a very, very dangerous assumption these days. The industry as a whole knows, and you know, that the standard captains, officers and crew in general have declined. The companies more and more are trying to control the ships from a telephone in an office. Now, if you start doing that, then the people just shrug their shoulders and wait for the phone call, telling them what to do. And this is occurring. So if these guys aren't going to do this, then, and you have to go on that ship and you've got to go into a place there, then now we talk of your responsibility for yourself. My advice is, no matter how good the ship is, and there are some good ships, believe me, still, and good captains out there that everything is done right to the line, but you cannot depend on that. You don't know that ship that you're going on, unless it's one like a ferry that you go on all the time. You've got no idea what's waiting for you. Don't even know what's waiting for you in the tank. How many rungs are missing on the ladder? You've seen them, I have. So you now have got to think. Oxygen meters, gas meters, take your own. At least you know it's been tested, and at least you know it works, right? Now, what about your emergency escape stuff? Are you going to take yours? Are you going to put a harness on? Are you going to go there? Because it's your life, you know. And I wonder if those things that the hurry in which sometimes you're under pressure to get it done, get the job done, and go to the next ship, is it worth it for your life? And I really do urge you to think about this. And the other thing that I think you've got to look for is you've got to look for some form of way that ship can rescue you if anything goes wrong. In other words, has it got people standing by just in case? Because I really feel that after all I've been through with the Mines Rescue Boys and seeing the precautions and what they do, I really would not go into a space I didn't know if I didn't see that there was people standing by with equipment that could get me out and get to me quickly and get me out. Huh? It's as simple as that. So responsibility for yourself, please. Do think that way. The more we all do this, the more we all say to the companies, look, you've got to get this stuff. You've got to get your people trained up. That the more that the pressure will be on them to do it. The more the pressure that institutes like yours and the Marine Institutes put on the IMO, the more the IMO is going to recognize that we've all got to do something to stop the deaths. Because I assure you, they're occurring, I don't know, we only see the tip of the iceberg. We only see the ones that are reported, and they are just the tip. But you can basically say that we're certainly getting over 100 a year. And I reckon that there's a good proportion of that are people like yourselves coming on board the ship from the shore. Okay, so my message is keep safe. That's about all. Adam.
Thank you, Michael. Just to give you a bit of background to this one, Michael and I were invited to speak in 2014 at your conference in Southampton, and we gave an enclosed space presentation there. Following the presentation, I was approached by Drew Korek, who's going to speak next, and he intimated to me about enclosed space rescue, from ballast tanks whilst there's water in them, and I said, no, we don't know nothing about this. We can't handle anything like this. And for one reason or another, we didn't actually get together on this, but earlier on this year, I was speaking to Drew, and Drew came across again, because he lives in Canada at the moment, came across to the UK, and we touched base. And he explained what he was looking at, and I said, yeah, there might be something we can help with here. So as part of this presentation, Drew's going to give the next few slides on submerged and semi-submerged work in enclosed spaces. Drew.
Thank you, Adam. As Adam mentioned a few years ago, I was an audience at the AGM in Southampton, our IIMS AGM, and came apparent to me that the issue of a rescue personnel working, engaged in the work inspections and what have you in the submerged or semi-submerged ballast tanks on board the ship. It's been not addressed and been clearly overlooked. My background is I'm a deep sea master myself. Spent a number of years with the Ministry of Defense as a Marine, and the diver in Royal Navy, and in commercial diving aspects on civilian sites. So I had a chance to see the both sides of the coin, both as a master and as the diving contractor who was engaged in doing work on board the ships. As you all know, there's no ship up there, a vessel which carry empty ballast tanks, except maybe time when she was built. So the possibility of you as marine surveyors being exposed to a situation that you may call upon a diving contractor to assist you in conducting inspection of structural integrity, inspection of the ballast tanks after grounding, to confirm that structural integrity of the vessel is still intact. And you may be asked to select someone or assess, make a risk assessment for this thing, or assist in their making risk assessment for those people. There are a number of issues associated with that submerged and semi-submerged confined space entries on board the ships, most from aspects of why and how, and why even people are getting in there. A reason for what I call it wet entry. In order to maintain your ballast systems in good working order, and by doing so, ensuring that vessels' ability to load, unload cargoes, equipment, and assure passengers' safety, it's absolutely paramount. As most of you being on the commercial side of deep sea vessels, either as engineers or masters or officers, and at one point or the other, you experience failure of the good working condition of a ballast system and ability of stripping them and pumping them in and out, either by failure of the piping system because of the corrosion, because of the substances carried inside the ballast tanks. As an example, I can give you possibility of the vessel loading sulfur, let's say in Vancouver, and bound for Brazil. By the time that vessel reaches Brazilian coast, the moisture from your cargo, which basically through the welds, through the ballast, it gets in the ballast systems and turning the ballast water into sulfuric acid. By the time you reach coast of Brazil, your 50% of the piping might be destroyed simply by doing so. Are you going to take your vessel out of charter? Are you going to go to dry dock straight up there? No, you won't. As a master, as a ship's crew, or whoever, you're going to do your utmost best to bring that working system, the ballast system, back to working condition, at least to finish your charter contract or arrive safely to destination, which allows you to do something about it. So that's just one of the examples. Diving contractors also, being called upon to do such work by ship's company to help them to resolve the problem, or by class society in order to confirm not only integrity but thicknesses. Myself, I've been involved in the very interesting project where we get on board the ship, one of the TK tankers in Anacortes, Washington State, and sail to Japan, where the two teams of divers with all applicable equipment conducting full cleaning of the side ballast system on the tanker while she was underway at sea, and conducting the UT testing while she was underway. Very interesting project. However, we encounter the same problems and issues as the mine rescue Adam and Michael talk about it. Who does it if there are no divers and you at sea? Ship's crew getting in there because they have to deal with the problems on board. Shoreside contractors, as we say, divers. What kind of work is carried inside? Yes, you may carry underwater welding inside the ballast tanks and confines. Emergency repair. Apply the coating. Do UT testing. Or remove the slash and debris in order to get the ballast system back in operational. Who else can go? Who is exposed to such problems? Marine rescue teams. Marine rescue teams would be exposed to a situation that they would be called to rescue someone who is inside the submerged ballast tank and closed confined. And yes, definitely there are no jurisdiction and there is no applicable regulations which deal with divers rescue from confined space entries. After my first meeting with Adam and Michael, I spent a couple of years of doing deep research into civilian sites and all aspects and looking far and near to find any regulations that are applicable, and there are none. Neither in UK, Europe, North America, South America. There's some applicable procedures which are created as a risk assessment to operations which have been conducted. And I've been exposed to such work and with my company in Canada and overseas, and we've done that. But when I was looking for something to go by or find some guidelines, there are absolutely none. What risk are we exposed getting those confined space entries? They're pretty much all across the same as a dry entry, with the exception of we have that liberty of having secondary breathing means of breathing air. But it's still confined space. Accessibility is absolutely difficult, as Adam and Michael mentioned. You've seen how difficult for a dry personnel is to enter the tank just with simple, light rescue equipment, harnesses, helmets, gas detectors. We don't need those ones. But as you see it on a picture here on the top of the slide, the diver, commercial diver, entering the ballast tanks with surface supply equipment still carry backup bailout tank. That's upside down tank which you see is upside down, so you're not catching up on the regulator and possibly bouncing that off. The diver you see on the picture carry 150 pounds of gear, which translates to 70 kg. It is extremely difficult in those conditions and takes quite a bit of strength for a human being to carry all that equipment in a best case scenario. Crossing to basically through manholes as small as they were described by Adam and Michael, you see by yourself how difficult it is to get in. To get out is the same, even more. If you encounter a situation, if any personnel become incapacitated, it becomes very difficult. The risk of exposure to contaminants by personnel entering those ballast tanks, as I mentioned, you can have even such extremity as sulfuric acid. Entrapment, if the personnel who enters those tanks is not properly trained, is not properly briefed, and have no idea where they're getting it. Because in most cases, the moment that diver hits the bottom of the ballast tanks, the double bottom, visibility is none. You got so much suspended sediment and particles in the water or substance which is in ballast tank, then you dealing with just environment with zero visibility. To become entrapped or disorientated is easily done. Additional equipment which is carried by divers, it could be anything which is needed to conduct the task on hand. It became apparent for us that it's relevant training and modified equipment is needed. Enclosed space entry training as dry and wet, enclosed space hazard awareness, familiarization with ship's construction for personal working in those enclosed spaces, and to be able to implement incapacitated personal rescue procedure in dry and wet conditions to those ones who actually are engaged in the task of doing so. As of now, I did another research and contact number of professional diver rescue training centers in UK, US, Australia, and Europe, and there's none of applicable training as mentioned or done here. The training facilities are focusing only on basically keeping individuals trained into diving procedures per se, use of the basic commercial diving equipment, pulse of the tools assessment, but confined space entry is not an option. The safety courses which commercial divers are taking, and that only in a dry conditions, they are not touching onto the rescue procedures. You would have a diver's rescue procedure which they encompass only up to the surface of the water. Beyond that, enclosed and recovery is not there. Last year, a few months ago actually, we met together at the Mine Rescue Center and we conducted over a period of a couple of days some trail in order to figure out how we can help the marine industry in resolving issues or bridging the gap, which is obviously there, in order to deal with the situation on hand and dealing with the wet, confined spaces and a personal entering them. As you see on the picture here, we did some dry tests using the basically standard size of manhole and standard size of helmet, which you see protruding from the hatch in portion of the individual shoulders coming through the hatch. As you see, it's almost impossible to get through. You have to bear in mind that helmet, which you see on a picture, weighs approximately 30 pounds. It translates to 14 kgs, and it's only supported by diver's neck. Everything is great if that diver is conscious, if that diver can assist the personal recovering him or getting out, it's fine. The moment that gentleman would become unconscious, it's easily done, and you actually can kill him in the process of recovery. It takes only 18 pounds to snap a human being neck and spine. If you imagine having 14 kgs sitting up there at 30 pounds, and translates, if that helmet become caught on the edge of the small manhole and you keep pulling him and recovering, you may end up actually doing more harm than good. And those are problems which marine rescue teams may be exposed to. And you may be exposed to dealing with situation on hand like that if you send someone and someone will literally pass out or become otherwise incapacitated. Currently, we are in the dialogue with IMCA with very positive responses from IMCA in order to come up with best proposed working practices for enclosed and semi and confined space entries on board the ships. The IMCA discussed with us those issues on hand, which we just presented to you, and they fully agree and supporting the idea of working on the subject. And that's what's our aim, to come up with a set of guidelines, proposed working practices. So you, as a result of that, you will be able to conduct your work in some safe manners and understand the problem. We are seeking solution to the problem and trying to bridge the gap, to train the solution. But it will be up to you to help us to implement that solution as a marine surveyor. Your knowledge of the issues and understanding that those problems is paramount. I'm sure that down the road, our aim is to be able to provide such training, the training for dealing with confined space entries becomes available to you. It will be something that we all going to be able to understand better and come up with and modify the equipment which is needed. Because that equipment for divers and possibly dealing with the different size of manholes will have to be modified. And what's our goal? To operate safely in a submerged or semi-submerged conditions of the vessels, which surely are integral part of that issue. As Adam mentioned in the past that he wasn't sure at the beginning, coming from mining background, how aspects of rescue are similar with if there's any synergy, if any overlapping issue and understanding of the rescue procedures between the mining industry and marine industry. And if you look closer at the subject, all those things becoming overlapping issues. At the end of the day, we're dealing with live people. You're dealing with the people's life. And like the way you're going to deal with those issues on hand, the knowledge, understanding, training, implementation, the final goal and result is to save people's life and protect people's life. And for us to be able to carry on with work, which will be carried out as long as the ships are afloat. Because there's no such thing as the vessel sailing up there without ballast systems, which they won't operate. You want to be able to control your stability. You want to be able to load or discharge the cargoes. And you're not going to happen that your ballast is not operating for some another reason. And you get called, the ship's master will contact the company and says, sorry, chaps, I'm going to take her right to the dry dock and forget about what I have on board because I cannot discharge her or load or otherwise. I hope that our presentation give you guys some food for thought and something to think about. And we're looking forward to be able, with assistance of IMCA and International Institute of Marine Surveyors, and you as basically people who will go up there and carry a torch and try to implement the solution to the problem and be able to come up with something tangible on hand and provide the strength. Go ahead, Allan.
Thanks, Drew. That was really interesting, that component part. Now, just to close now and recap on what we've been talking about. When we set out on this journey, we envisaged that it was going to be a short journey, but in actual fact, it's been 8 years now. And the 4 things that we came up with and made into the confined space box are, as you can see them. We've dealt with the equipment side. We've looked at the design problems associated with enclosed spaces on board ships. There are training problems and these need to be addressed. But the one issue that we haven't had a look at yet is culture. Now, I'm afraid that culture sits with you. Until things change, everything stays the same. You go into a ship, you do what you need to do, and you're guided by the culture on the ship. If we're able to educate you people and tell you, look, you don't have to go with that, you need to look at the issues associated with this and protect yourselves when you go on the ship, you will start and begin to change the culture. So it sits with you, gentlemen and ladies, and that's where we're going to leave it. I'll just thank you very much for your attention. Thank you.